So part 3, example 2. This time my iPad ran out of space, so I have to use my phone now to video this. I'm really sorry, guys. I'm as frustrated as you are, maybe more. Anyways, let's continue and finish this example because I'm certainly done with it. So FTA equals Fs equals mu s Fn total, which is equivalent to the total gravitational force on that, which involves the total mass times gravity. So we get mu s times m1 plus m2 times g, plugging in 0.22, 27 plus 38 times 9.81 equals a whopping 140 newtons. So that's part A. Part B, what is the tension in the rope between sleds 1 and 2? So because we're looking for the tension force and because it becomes eliminated in the system diagram, we're going to look at one sled at a time. And the sled 2 here, he's going to have just this tension force going that way and the static friction force going that way. If we dealt with sled 1, we'd have the applied force and the tension force and the static friction force. So there's 3 forces involved, and I don't want to use that because that's too much stuff. So let's just deal with sled 2. So draw the free body diagram, always first thing. Always step 2 is the net force equation. Do you see a pattern coming along here? So it's always free body diagram, the net force equation. That's going to be equal to mass 2 times A. And the forces here, Ft, take away Fs equals m2a. Solve for Ft. And now we're just dealing with the static friction force of the second sled, so I'm only dealing with his mass, or her mass. So m2a plus mu s, fg2, m2a plus mu s, m2g. Again, if you want to impress whoever, factor out that m2 and get this lovely formula here for the tension force. Plug in your numbers. Oh, acceleration 0. I almost forgot. It's getting late here. So because they're not moving, the acceleration 0, so that's okay. We're going to plug it in here. In our last bit of our problem solving, and then go plus 0.22 times 9.81 equals 82 newtons. Nice round number. So there you have it. After 3 relatively short and less frustrating videos, you have example 2. Let's revisit, just summarize. Draw a free body diagram of the system. If the system looks too messy when you do that, draw a simplified diagram of the system with the forces involved on the outside of the system only. Treat the mass of the system as the total mass. So you've drawn your free body diagram. Write out your net force equation. If the system is not accelerating, A is 0. Solve for your missing quantity. Part 2, if you're looking for the tension force, treat the system now as one object at a time, because that's where you're going to find that force you're looking for when you draw that free body diagram. Write out the net force equation. Don't forget it's equal to 0 because it's not accelerating. But if you do forget, that's okay. If you carried it around like mine, that's okay. It'll all come out in the math when you sub in numbers. And you get 82 newtons. Thanks for watching. Example 3 coming at you in a second.